Good afternoon. Today we're going to cover our ProScan probe calibration. So we're going to go ahead and start by double-clicking on our ProScan software. You're going to see a pop-up in the center of the screen when it starts to load, showing your software version as well as your registration date. So if you have your ProScan connected, it'll pop up and say acquisition mode. If it doesn't say acquisition mode, you're going to want to double check the USB cable as well as the ProScan. Make sure it's connected. So we'll click on A scan right here. We'll go ahead and continue from our last file. So you'll notice we have our signal right here. We're currently on a 1/2 inch block. One thing I did do from our last project, we had auto height turned on. I'm going to go ahead and turn it off so that we can drag and drop our signal as need be. You'll notice our current gate range is from 25 mils to a 1/2 inch and slightly more. So to do our calibration, we're going to click on transducer, verify we are on pitch catch. We have a dual element probe. I will go over a calibration on a single element probe as well. Longitudinal is correct, so we'll move right along to calibration. So we're going to start off doing a 2-step calibration here. So we'll simply move the probe to our 200 step. We're using a CS1 probe or CS1 cal block. You're going to want to make sure that you're not setting up on the hole, because there is a 10% hole here and that will throw your stuff off just a little bit. So we'll simply type in 200 to correlate with our step, hit set delay. You'll notice the signal moved to 200. Now we will go to our 1/2 inch step, which is right there. We'll move it around. Now we can simply drag and drop our gate over here. So we're going to hit set velocity, and you'll notice we're right here at a 1/2 inch. Now if you move your probe forward a little bit, you'll notice a slight change in the signal as we start to go over the hole. So you have your 1/2 inch step, and there's your hole popping up right at the start. Then we can just verify it. So we're getting good signal. We're hitting all of our steps. We can move our gate back. And now we can pretty much just run all the way from 200. So 500. Good afternoon and welcome to our AUT Solutions training videos. Today we're going to be going over a complete setup from a calibration to scan acquisition. We are going to be using the AccuTrack. AccuTrack and AccuScan are highly similar. The only difference is the AccuTrack will be serial, so some of these options might not apply. One of the biggest things when you're getting set up is to make sure that you have all of the proper equipment connected.
Set our velocity.
So you're going to want to have the ProScan connected to the laptop as well as the motor controller via the ENC cable, as well as your UT lines plugged in.
And our
just
200
to give you
all
a quick
coming
little
in
grasp, so we have everything plugged in. I'm going to
that covers
my
our
ProScan
transducer calibration section,
and go ahead and click on our ProScan analysis.
Contact support.
Now, without the USB cable connected to the ProScan, there's no communication for the computer. So you'll notice as it begins to go through and initialize, since the ProScan is not hooked up, the only option that we are going to have is analysis mode. So it says hardware not detected, entering analysis mode. So we are going to go ahead and click OK. We're going to close this out because this can commonly lead to another problem. So if this is the first time that you are setting the system up, you might not have a device driver. So if your ProScan is plugged in, we just got the little beep saying that it is. We're going to go to the control panel. And we are going to go to hardware and sound. We're going to want to go to our device manager. So up here you'll see the BrainBench Technologies device. Now it's showing that it has the correct driver loaded. You might pop up and find a question mark here. If you do, you can right click, press properties on the right one. So we'll right click and go to update driver. Now, with the ProScan software, you do have the drivers included in the software. Sometimes it won't load them, sometimes it will unload them. So when you go in, you can click Browse on Device. So we will click Browse over here. I'll show you where the drivers are. You go to Windows C Drivers. Well, let's see. And there it is. I missed it myself. We got drivers for ProScan. Select your correct operating system. Click on that, and that will solve the problem there. So a little bit of troubleshooting mixed in today. All right. So now we have the ProScan plugged in, the drivers correctly installed. We're going to go ahead and check our AUT controller. However, I have my lovely assistant getting it set up for scanning right now. So if you don't have the motor controller plugged in by a USB cord, you will get the following error message. It'll act like it's loading, pop up and say hardware not detected yet again. We're live. So you'll notice it is now going through the motion control. It is plugged in and on. So we now have control of our scanner. Now we can go over to our ProScan. One thing we're going to want to do though, we'll go ahead and close this out, because once we're in the ProScan, if we click on motion and it's already opened, it'll tell you to close it out anyways, so we're just going to prevent that step there. So now you'll notice we have the driver installed, the ProScan's hooked up. We are in acquisition mode. Notice before it said analysis because we did not have a ProScan hooked up. So we will simply click on A scan. Now it's going to pull up a couple different options for us. We did record another one of these videos, so as round 2, we're going to go ahead and start a new one. If we wanted to continue on the last one, we'd simply click continue, or we can go here and open that one. However, we're going to name this AUT AccuTrack. Alrighty, so now we have a new file name, and you'll notice we save all of our files under the ProScan projects file. You don't want to put a file inside of the AUT setup or the AUT video series folder, because if you put two projects in the same project folder, you'll have some data corruption there, and it becomes quite difficult to recover files. So the easiest way to do it is just make sure you're in the master projects file here and not the master project here. That is where we will receive all of our missing information, or if we ever have to restore the software to kind of the ground level, we will do that as well. So we're going to go ahead and save it. You'll notice that our project name is now displayed at the top here. For some of you that might want to dive in a little bit deeper than this video covers, under the help, you'll notice there's a manuals button. What that will do is pull up the user's manuals for the scanner. So you have the laser scanner installation and operation. You also have the ProScan software manual. Now, if you were looking for your scanner specific manuals, you'll click on scanners, go to, oh, hold on, we went a little too far. So we will go to AUT Solutions, AUT Controller, Manuals. There you will find the product-specific manual to cover all of the different scanners, and any installations, hookups, maintenance, troubleshooting would be found there as well. So just a little quick overview of the help menu. All right, so the piece that we are currently going to inspect is a half-pipe calibration block that we had custom built for our demonstration purposes. So we're going to go through and set the data up accordingly. So we're going to start with our settings job information. So AUT Solutions is the customer. You have your technicians, the job site location, date of inspection. You also have your component information right below. So the material thickness on this piece is nominal 322. We have our AUT inspection procedure. Our acceptance criteria are client specific. You can also punch in the number there as well. So we have no coding on this. The coding has been removed. We're not going to need coding correction or temperature correction. And we also input the material diameter so that we can do our 3D renderings in the post data analysis. All right, so now we're going to go into our color map setup. Now you'll notice here we do have our color scale value for our B scan. This will be important. So if you ever have any color problems here, which we did in one video, you want to make sure that red is 100% and blue is 0. So I had it on reverse colors on one of our videos, so I will adjust that now so our color palette will look correct. So if there is no reading, the back of the screen will be white. We're going to go into C-Scan. We're going to select Processed here. And that is two different options. Process will save the B-Scan on the screen. Speed will erase it every swipe. So we have our color palette set up currently to do from -50 mils to a 1/2 inch. However, this piece is not that thick, so we're going to modify that. We'll go to 400 just in case there's any deviations. So anything over 400 will currently come in purple. However, if you right click or left click, if you hit the right button, we're going to go to blue and just kind of make it match a little bit. Same thing down here. You can left click on this area and you can even change it to white if you wish. So some customers will prefer it to be black. So we'll just go with white and black for now. So we have our color maps set up. Moving on down, our encoder calibration is automated, so we can go in and verify that here. If you needed to, you can simply measure out the distance, move the scanner that distance, and verify these encoder counts are correct. The encoder counts are actually pulled off of the motors themselves versus a physical encoder, so it's very hard for these to slip. These counts normally don't change. If there is an error and the counts deviate from this, you can either refer to this video or the user's manual for the appropriate scanner counts. So next thing to go into, units. If you needed to change your units into millimeters or centimeters, you can do that here. We also have a touchscreen mode for those of you using touchscreen laptops. However, we do discourage this unless you're not using a keyboard. If you accidentally click this, it will disable the keyboard functionality and you might have some problems there. So moving on in. So we currently have our scanner on the AUT CS1 block. We're on the 200 step. So you will notice here we're coming in at 216, so we're going to need to do some calibration. So we're going to move over to our calibration block. We're going to do two-step block calibration. Our CS1 block has increments of tenths of an inch. So we're going to simply click 200 in here. Click set delay. You'll notice the signal adjusts. I want to check and make sure. So we're going to want to turn off our auto height here because that can cause some issues. So now I'm going to have our amazing assistant. We'll do that one more time. He's moving it. And we will see he might have moved it a little bit faster than I can click. So we will go in here. We'll set our velocity. And you will notice it kicked it way, way out. So since that came in wrong, we're going to just go ahead and we'll change our velocity back to longitudinal. We'll just punch in a value here, change our delay to 6, which is a good place to start. So he is going to move it back to the 0.2 of an inch spot, which we're at. So we will click set delay. One thing you'll notice, my screen range isn't long enough for this, so we're going to change that to 1 inch right there. Now he is going to move it over to the 1/2 inch step. Now one of the nice things with the newer software, you can drag this gate down if it's not long enough. So we're coming in correctly at 0.497. We'll just verify this real quick and I'll have him move to the 0.4 and the 0.3. So we are within calibration tolerance there, as we are only 1 mil off. So we are now good to go there. A couple things we're going to want to run through real quick is we will now remove the block from the test piece and we will put the probe down and make sure that our gain settings are correct. We can do some range adjustments here as well. Couple things that we can go over real quick. So you'll notice we have a good screen height. Signal's a little high, so we're going to drop it down to 80%. Alright, our screen range is a little bit longer than what we need to, depending on what your procedure says. Some require 2 back walls. If that was the case, I would simply come in here, change it to 0.7. Now you have your 2 black walls displayed. However, we don't need that right now. If you did need this, once you set this screen in the A-Scan settings and complete your scan, you can't go back and change it. So it's better to record it with 2 back walls and then crop it out during your scan than it would be to just acquire data without that second back wall. However, our procedure doesn't require that, so we are simply going to change this to a 1/2 inch to make sure we get both sides. So if we have a decrease in wall or any blisters on the inside, we'd be able to see that additional information down to a 1/2 inch. So we're going to go in. We got our filter set for a 5 meg probe. If you were running a different probe, you would simply come in here, select it from the drop down. You also here have the ability to change it into a RF signal. Your fully rectified signal, which is what we typically scan on. You have negative rectification, positive rectification, and your envelope. So we will go fully rectified as we're running our gate on 0 cross. Now if you had to use a different wave mode, say that you're required to run a negative rectified scan, you could simply come in, change this to first peak, and now you're getting your first negative peak through the gate. Same thing if you switch over to positive, you'll notice the phase shift and the time change as we are now recording the first positive peak through the gate. So if you wanted to get the maximum peak through the gate, you can change that there. Now you will notice it's reading the maximum peak here and not the first peak. The only problem with this is as the amplitude changes in the screen, you will switch signals, which could cause a deviation in a couple mils, which might be out of code pending your procedure. So what we like to do is run 0 cross because it actually captures the time on the RF signal where the signal first crosses 0. So you'll notice here we have a positive first half cycle. At that 0 point where the signal starts to go negative is now where we're capturing data. So as the amplitude changes, that reading does not change very much. So we're going to go back over here. So we got it on 0 cross. We're going to change our signal back to fully rectified. We'll turn on auto height, which will allow the system to add gain to keep the signal in there up to 10 dB. So we have our auto height set. Our gate is going to be at 20% screen height. Our range, we are going to cover all the way down to a 1/2 inch. So we'll just adjust that. Change our start. Auto height, screen range looks good. Now you will notice that the gate is a little bit off the screen. We'll simply come in here and change that to 2.1. Now you do have the ability, you'll notice right here, that the gate can be dragged and dropped. However, we changed the start, which pushed the end back. So we can simply go over here. And we will adjust our gate right here. So we will change this to 0.050. We will change this to 0.5. And we should be good to go now. So we're going to set up and run our first test scan. Oh, and also if you needed to run multiple gates, you would change that here. So if you needed to do a 2 echo to echo gate, you can turn that simply on and off right here. Same thing with gate 3 or an interface gate. You'd simply just come over and turn the gate on or off. Alright, so you will notice I was trying to drag and drop the gate. However, with auto height on, I just learned you cannot do that. So, if you needed to drag and drop your gate to move it into position, you would simply do that here. Now that we have auto height on, I can't do that. I have to change it here. Now, a lot of you might be saying, hey, what's that second signal coming up at the back? That is the shear mode conversion from your longitudinal signal. Alright, so now we have our gate setting back at 80%. We have our auto height on. So we should be good to go. A couple things you want to check. If you need to run a distance amplitude correction, you could do that here. It's super simple. You would find your point, click add. We'll cover this a little bit more in depth in its own video. Add, update, insert, remove. So if you need to run that, please see our DAC video. Our transducer settings here, you'll notice we have our transducer model number. input our probe serial number, our angle, which is a dual 0 degree. So it's all one probe, so this information matches up. We've already completed our calibration. If you needed to run a FFT on your signal, you could do that here. Haven't seen much use for it in the corrosion mapping world, but if you're doing HTHA inspection, that's one of the requirements. So one thing that we're going to do real quick is click on motion. We're going to load our motion control software for our scanner, which is currently the AUT scanner. Now the only difference between the AUT and the AccuScan is the AUT is steerable, thus it has 2 X motors and 1 Y motor. If you're running an AccuScan, it just has 1 X and 1 Y. So one of the differences you'll notice here is you have 3 motors that will pop up green saying all of our motors are currently responding to commands. So we will currently go through and run through real quick. You'll notice we have our X start and stop. These would be your scan increments. If you're going to run a 100-inch scan, you would simply input 100 into the stop. Now your scanner will run from 0 to 100. However, for this video, we are going to run 10 inches. Same thing with your Y. We currently have a 20-inch arm on the scanner, which unlike most of our market, our scanner arms that are 20 inches move 20 inches. So we want to tell the system that we have a 20-inch arm in here. If you need a larger or smaller arm, we go all the way down to 12 inches, all the way up to 48 inches. So give us a call. We can get you more arms if needed. So we have our exam positioning set. We're going to run at 1/4 inch increments on the X axis and 1/8 inch increments on the Y. If you need to move your scanner into position, you'll notice we have these arrow boxes over here. Left and right are your forward and back direction correlated to your X motor. Up and down are your Y arm. So if you need to move your Y arm over, you would simply click up. If you want to move it down, simply click down. You'll notice there are some values sitting here. You have 8 inches. This is going to be your Y arm movement speed when you hit this button. And your X movement speed here is 1 inch per second. So you can technically move that up to 2. It'll move a little bit quicker, or you can slow it down and adjust it. These values for speed control do not correlate to these. These are your inspection speeds, and these are your movement outside the inspection. Now with the AccuTrack, you'll have an additional panel here that will show you XX. This will give you the ability to steer the scanner automatically. So you have the left motor on top and the right motor on bottom. So you have the ability to steer each one of them independently. Now if you needed to move it a little bit more precise, you do have the option with the AccuTrack to click on joystick. It will give you a virtual joystick, which will then allow you to drag this blue dot. You can move it in any direction that you want. The scanner will also follow. If you need to move the Y arm, you would use these two buttons here. Just simply click and press, and they will move. So if you do have the Bluetooth joystick controller or a wired joystick, you could simply plug those in with this screen up, and it will not say virtual joystick. It will just say joystick in use, and you could use those to control the scanner as well. All right, so we have our exam setup entered. We have our arm length entered. If you needed to change the units here, you could do that under here and change it to millimeters or centimeters. We're going to index on our x-axis, meaning that the scanner will swipe on the Y and increment 1 unit forward, which here is a 1/4 inch on the X, and then perform another Y raster. Now, if you needed to change that movement pattern, you could simply switch to Y, and it would move the scanner forward 10 inches, increment the Y, and then move it backwards 10 inches. So you do have that scanner pattern choice here. So we will go into position setup. Our scanner is currently set to 0, 0 on X and Y. So we will go in and 0 out the X by clinically typing in 0, clicking set. And our Y is at 0, so we will do 0 and set. Now if you do see any negative numbers or any variables in here that just change without the scanner moving, you might want to come over to scan, click reset motors, and you will notice we have some negative values pop in as the encoder boards on the motors themselves are resetting. So now you will notice when you go back to position, you're at 0, 0 yet again. This will solve probably about 50% of the motor problems you might encounter in the field if you have a power spike or a glitch or some minor electrical interference. So now that our exam setup, our position setup, our arm length is entered in here, we can now get ready to scan. One thing I want to run through real quick. You'll notice right here it has our software version 7.4.49 and AccuTrack behind it. That is because we are running an AccuTrack scanner. However, if this is your first time setting up a system, it might default to AccuScan, which you'll see right here. To fix that, you can simply come and select AccuTrack and it will reload the software program. Same thing with the Armalite, mobile, or thermal scan. Now, some customers will run an AccuTrack and it will populate and say AccuScan. You'll notice that if you have an AccuTrack and you don't have this XX feature, that you need to reset and go back to AccuTrack. The other options that we have here, if you're setting up for a B scan, you do have the ability to go into single axis mode and disable your Y. So you can move your Y into position of the center of the scanner. Simply click disable Y axis and you will actually go in and remove the exam setup Y, and it will simply drive forwards and backwards for you. A couple other things that we might want to go through is about it. If you want to label your accesses, you would simply do that here. And it looks like we're good to go. So what we're going to do, our first scan is always highly recommended to be the test scan, because 9 times out of 10 there is a simple small feature that we forget to set up that would allow our scan to come out the way that we want. So we will simply go up here, click on acquisition in our A scan settings. We will select C scan. If you were doing a B scan strip scan or a manual B scan, you would select B scan right there. So we will go ahead and go into our acquisition window. So you will notice down here you have scan sheet reanalyze. These are features that will be available after the data. If you needed to add any soft gain in here or software gain, you could simply right click on the A scan and you can add or subtract gain here. If it's a huge difference, you might want to go back into your acquisition software A scan and decrease your gain. Alright, so now on to our test scan. So we will go ahead and hit start. We have water to the scanner. Now you'll notice there's a 3-second pause in between the start and the actual movement of the scanner. This is a safety feature to make sure everybody's fingers and toes are out of the way of the scanner. So you'll notice we seem to have a good back wall signal coming in an appropriate distance. We did have a little bit of data loss right at the start. Looks like there is some water issues. We can simply correct those. Now, if we caught that right at the beginning and you want to stop the scan and go back there, you can simply go, pause the scan, click on the area you want it to drive back to. It will ask if that's where you want to move the scanner. We will say yes. Now that it is nice and wet, we will resume it, and you'll see it's already overwrote some of the data. So we can now resume our scan, and it will go back and scan again in those exact same areas. Alright, so we are now starting our scan. We got some additional water right at the front. So you'll notice it's going back in. We captured some of the missing data points. We're getting a nice straight back wall. Our color palette seems to be in line with what we are looking for. So now it's just a matter of the scanner scanning. So we will notice that there are still some spots here. Looks like we have some minor corrosion, possible pitting right there. I want to go back and have my technician mark that area up so we can go back and see what it is. So I'm going to pause my scan real quick. I will click back in here, and now you have the ability to drive the scanner back to that position. You'll notice the scanner is going to move back to that. My technician is going to mark up that area. He has completed it, so now we are going to resume our scan, and it will continue from that point. So you will notice you'll be able to start to tell whether the scanner is going back and re-recording. You can see some of the indications popping up in your B scan. Looks like we have a nice little bit of corrosion there. Now you'll start to notice that some of these defects look quite pixelated. If you needed to go back and do some in-depth analysis, say you think you might have some possible stepwise cracking or hydrogen blistering, you could simply stop the end of the scan and we'll go through that. Just take a quick second. We'll let this scan complete real quick. Alright, so our scan's complete. We're going to go ahead and click Accept Scan. It's going to pop up and ask us to save the data. Yes, we're going to save it as scan 1. We will hit save. So now we have our data. We're going to go ahead and full screen it here. Now it's up to you on when you want to do your screen captures. If you want to do a screen capture that just captures the raw data at the end of the scan, at this point you could simply click capture and you will have a data file that you can capture there. You can also go in and go to setup. So if you wanted to box out your window and capture just your C-scan, we could do that. Now if you wanted to capture your full window, because we do have it full screen, simply click capture. Now you have your full screen. We can right click and save it to either our instructional video series. We can save as screenshot 1 just to help keep data organized. So we will exit back out of this. If you notice that nothing's working on here, it's probably because you're still in your capture window. I do that quite frequently. Now just running through the data real quick, we'll see that we have 1, 2, 3, 4, 5, 6, 7 areas. Now typically there's a couple different ways to do this and we'll run through a couple right quickly. So if you want to see your lowest thickness reading, you can simply hit statistics and it will go to your lowest thickness reading, which is 0.134 here. Tell you the average thickness of the C-scan window, and it will also tell you the standard deviation, total number of readings, nominal thickness, which is 0.322 here, and your average remaining wall in that area. So you can record that to the scan sheet. So we do know we have some general corrosion here. So we will type in general corrosion and record the scan sheet. Now when you click on your scan sheet here, this will tell us that we have to leave acquisition mode and go into analysis to see, so we don't want to do that just yet. So we have our lowest reading here, and now if that was, say, a coating blister bubble or anything of that nature, you can go through and correct that. The other thing that we can go in here, we can smooth out our defects. Now they look a little bit more like defects. You can turn that off as well. So what we're going to go in and do is I'll run through how to size indications manually. So you can simply turn your flaw cursors on. You'll notice you have 2 flaw cursors that come up, and if you get them just right, you can drag them in multiple axes right there. So we'll position this one right here because we just want to know what the lowest reading in that area is. So we have that. We can rerun statistics. Now it will pull up the minimum thickness in that area as well as the total readings in that area, nominal wall loss. You can record that to your indication table. We will call that indication number 1. And you can continue to do that to all of the other ones. So we'll go through, we'll mark up indication 1. We'll move to this one. We will call that one indication 2. Simply click statistics yet again. Record the indication table. Call that indication 2. Then we can come over to indication 3. And this helps a lot if you're using a heavily pitted surface area or something that will chip paint, loose paint. A lot of times you'll get some erroneous signals. This allows you to kind of negate them out. So now we'll record that. Call that indication 3. Come over. Mark this one up. Now we're not quite sure if these interact or not. Some procedures have interaction criteria. Some clients do as well. It doesn't look like we have a huge separation in between these two. So we can do this one of 2 ways. So we will box it all up. And that is one indication. So now we'll come to statistics again. Mark that up. Call that indication 4. And we have one more tiny little fellow over here that we will call indication 5. Now depending on your scan area, you could, and the vessel, you could have quite a bit of indications to record. I have some that are 120, and this would take some time. But you'll notice now we have all 5 of them marked up. I'll show a quick way to do this here in a second. So now we can simply right click and go to indication table. You will see we have all 5 indications marked up: start, stop, lengths, minimum thicknesses, average thicknesses, and any comments on those. But to make it fast, we'll go ahead and delete those real quick. And I know a lot of people are cringing in their seats and saying you just wasted a lot of time, but there's a time saver that we can do now. So when we started this project, the client said, hey, we have a 50 mil corrosion allowance on this line. So we're going to go in and set up our auto indication features. So you would simply type in your 50 mils, which is already here. Now your XY interaction criteria as to whether a flaw interacts or not. This is pulled off of your material thickness. Same with the corrosion allowance. So if you have the appropriate thickness in here, which would be your average or your average piece thickness, type in your corrosion allowance. Now we can simply go in and right click in the C-scan, go to auto indicate. And now it has all of the indications. You'll notice there's a couple up here at the top end that we didn't mark up, but it has now marked up 9 indications based on the allowance and the interaction based on the material thickness. So we went from having 5 areas to 9. So this will also help if you have any technicians and you want to go back through and audit data. You can do the auto indicate to make sure they're in line with the procedure, the client's specifications, and make sure that there are no indications missed, because sometimes when you leave it up to humans, we can miss things. Alright, so there's our automated markups. We can also go in, a couple more things that we can run. If you wanted to go in and look at these in high definition, you can go in and zoom to a window, and now you're simply looking at indication number 3. You can make any adjustments that you need to, or go in and mark up accordingly on a smaller screen. So just one last quick thing before we wrap this up. We are going to now go back in, so we're going to exit out of this. Yes, we will save our marked up. We will overwrite that. Now the original data file and the analyzed data file are 2 separate files, so we're never actually overwriting the original scanned data. We're simply creating a new analysis file for that. Alright, so we're going to go back into our A-scan real quick, and we're going to show the difference in the data presentation based on increments. So we can go back to our C-scan acquisition. So we did save that screenshot. We'll compare the next one, but I just wanted to show you real quick what a minor prove-up will be since we did save that. Let's see the area that we want to scan. So we can simply pull up our screenshot real quick. So we will look at our screenshot real quick and see that our general corrosion area looks like it starts about 2.5 inches into the scan. So we don't typically need to rescan the entire area that we already know is good. So I'm going to go back in, and we haven't moved our scanner. So one of the nice abilities that I have is I can come back in and tell it I want to start at 2.5 inches here, and we're going to still scan to our 10-inch mark. So we will get a little bit of water going real quick, and I will come over. So we're going to change these increments into 50 mils, and we're going to change this down to 1/8 of an inch, and we will restart our scan. So you'll notice the scanner moved back into position. Now you can see it reacquiring data as the Y arm rastered back into position. Now you'll start to notice we're actually picking up a little bit more detail around the edge of some of those indications. Looks like we have the start of some general pitting, and this will also allow with some better analysis when it comes to characterizing the patterns that you're seeing. Whereas that looked like general corrosion before, it looks like it's just isolated general pitting. And now we're starting to come into the second flaw. Looks like it's some general corrosion. So you'll also notice the signal seems to be attenuated quite a bit when it hits the back wall and is scattered around due to the round nature of that indication, which also helps with classification. Same thing with the third defect. All right, so our scan is done. You might notice a couple things right off the bat. We do have a lot better definition of the edges of the flaws, as well as two of the ones that were isolated at the top right-hand side of the screen. We'll go ahead and save this as scan 1-2, since it is the same area. All right, so one of the things we're going to do real quick, we'll go ahead and do a side-by-side comparison of the screen capture. So we will simply capture this screen. Alright. Go over. Alright, so we have our screen capture. We're going to right click Save As, and it'll pull up the same screen that we had before. So we'll call it Screenshot 2. Alright, now with both of those saved, let's pull those up real quick and compare them. Now you will notice one scan took twice as long as the other due to half the size. However, you will notice the highest difference in the detail between the two. So we have that one, and then our first one. So you'll notice that there's a lot more detail in the second scan when compared to the first. So your isolated pitting looks a lot more like isolated pitting. Your general corrosion and erosion, you'll notice this one had some spots where it didn't hit data, whereas these points look a lot more like the shapes of the actual defects. So one thing when taking into consideration, large areas might not be able to need to be scanned, but more screened in higher increments, and smaller areas screened in detail. But yet again, that's up to your procedure. So same thing, we're going to just go ahead and take this data real quick. We are going to right click. It's still the same file, so we don't need to reconfigure. All the information is still the same, and we will simply let the system mark it up for us. So now we can click Auto Indicate. There you go. Indications are marked up. If you want to make a pretty picture, we can turn on smoothing. You'll notice with the more intricate, detailed scans, you now have a better indication. You can see your isolated pitting. You can go in and mark these up simply by turning flaw cursors on or off. You can delete your indications, modify them as need be, and then of course do your screen capture for your report. Alright, that's the end of this, and the next video series will be an in-depth look at setting up your DAC and TCG. Until then, have a great day.